Okay, chapter 1.5, special angle pairs. How can I identify and use special angle pairs? First off, we should define some of those special angle pairs. So the first one is adjacent angles. Adjacent angles are two angles that share a vertex and a side. So an example would be, like, I don't know, this. Angle 1 and angle 2. Those share a side right here in the middle, and they share a vertex. So adjacent angles, adjacent means next to. So adjacent angles are just two angles that are next to each other. They share a vertex and a side. That's all there are to it. All there is to it. Vertical angles. Vertical angles are very important ones. Those are stressed in geometry a lot, so you should definitely know what vertical angles are. Vertical angles, I'm going to do the example first. Vertical angles would be like these two. Vertical angles are when two lines intersect. Vertical angles are the angles across from each other. Turns out that they are congruent. So whenever two lines intersect, there's actually going to be two pairs of vertical angles. So they're the ones I marked right there. And then these ones are also vertical angles. So I've got two pairs of vertical angles. So vertical angles are angles across from each other when two lines intersect. Important note, they are congruent. All right. Complementary angles. Complementary angles are angles that sum to 90 degrees. An example would be if I had an angle here that's 40 degrees and an angle over here that's 50 degrees. Those are complementary. Supplementary angles are angles that sum to 180 degrees. So an example, maybe I've got an angle here that's 120 degrees, and maybe an angle here that's 60 degrees. Those would be supplementary angles. Now, with supplementary angles and complementary angles, I'm going to put another example because you'll often see them not as separate angles, but you'll see them together. Like if I gave you that, those two angles there, those two angles form a line, and lines always add up to 180 degrees, so they're supplementary for sure. I'm going to say this one's 130. If that was 130, the other angle would be 50, because lines always add up to 180. So a lot of the times you're going to see supplementary angles like that. Same thing with complementary angles. If I had a 90-degree angle, don't forget the way to show that is with a little box in here. But then I took that 90-degree angle and I split it into two angles. Those angles would be complementary. Maybe this angle is 70 degrees and the top angle is 20. All right, so two different ways you might see them. Together as a single thing or two separate ways. All right, this one in particular, supplementary angles that are together, they're given a special name. They're called a linear pair. We're going to talk about that in a little while. But first off, I'm going to take just a break. You might be a good idea to work through these problems to make sure you understand the different things: adjacent angles, vertical angles, complementary angles. Maybe put the video on pause, just go through those questions and see if you can get them right. And then I'll do them for you and you can watch. Okay, so BFD and CFD are adjacent angles, true or false? Well, here's BFD, BFD, and here's CFD. Oh, that's a tricky one. I didn't catch this when I gave the definition. The definition is adjacent angles are angles that share a vertex and a side. So yes, that fits my definition. They share a vertex and a side. But no, they are not adjacent angles. This is actually false. I missed something in my definition. They share they share a side, they share a vertex, but they're next to each other. Like the whole thing adjacent means next to. So they are next to each other. So adjacent angles are next to each other. They don't overlap. There's one on one side and one on the other side. So these ones, that's actually false. Those are not adjacent angles. They are not next to each other. False. I'm glad that question came up. All right, let's do the next one. Are angles AFB, so AFB right here, and EFD, are they vertical angles? Oh, well, they're vertical angles as long as they're the angles caused when two lines intersect. Let's erase these so I can see a little bit better. That is definitely a line. That is definitely a line. Oh, but when those lines intersect, the one angle right here and that angle, those are vertical angles. But this is AFC, not AFB. AFB isn't that whole thing. That's just part of the angle. So again, false. Vertical angles happen when two lines intersect. Just because they look like they're across from each other, this one and this one, they look like they're across from each other. They're not vertical. They're only vertical if they're the angles caused when two lines intersect. I'd have to have that entire one for it to be a vertical angle. Dude, I like these questions. These are good clarifying questions. All right. Last one. AFE. AFE, this angle right there. And BFC, that angle right there, says they're complementary. Well, if they're complementary, they add to 90. If I take 62 plus 28, that is 60 plus 20 is 80, plus 2 plus 8 is 10, that's 90 degrees. So true. Complementary angles add to 90. All right, there are a couple more true or false for you to try. If you want to check them out and make sure you got them, that'd be a good idea. I'm going to move on though to keep this video short. I think those first three were good indicators. All right, oh, you know what? I'll put the true or false real quick just so you have it. All right, so if you tried it on your own, we have true, false, false for A, B, and C on the you try section. Okay, moving on. Linear pair, I had talked about this before. A linear pair are adjacent angles. Adjacent means next to again. That form a line. An example would be those two angles, angles 1 and 2. The two angles that are adjacent, they're next to each other, and they form a line. Angle bisector. An angle bisector. Bi means two, sect means cut. So an angle bisector is something that cuts an angle in two. Specifically, it cuts it exactly in half. So an angle bisector is a line or segment or array, I suppose, that cuts an angle exactly in half. So for an example, I'm just going to make something that looks to be an angle bisector. That looks like it might cut it in half. But in geometry, again, be careful on looks. Just because it looks like it cuts it in half doesn't mean it does for sure. However, if I put these tick marks here, one there and one there, that indicates that the angles are equal. Now that ray is an angle bisector. If we wanted to give it names, we could. Why not? Let's call this A, B, C, D. And then we could say ray BD is an angle bisector, because it cut that ray exactly in half. All right, some applications that involve algebra. All right, so these two angles, the 2x plus 24 angle there and the 4x plus 36 angle there, those form a linear pair, which means they add up to be a whole line, and lines add up to 180 degrees. So that means I know those two angles added together should sum to 180 degrees. They should equal 180. So that's what I'm going to write. I know 2x plus 24 plus 4x plus 36 equals 180. The first angle plus the second angle, that equals 180. Then we just do the math to figure out what x is, right? I've got a 2x and a 4x on that same left-hand side of the equation. We can add those together. 2x's plus 4x's, that's 6x's. That 24 and that 36, we can combine those together. It's called combining like terms. 24 plus 36, that's 60. I didn't do anything with that right-hand side yet, so that's still 180. And then we just do the math to get the x by itself. Again, we want x by itself, so I got to get rid of that plus 60. Opposite of adding 60 is minusing 60. So I'm going to subtract 60 from both sides. When I do that, I end up with 6x by itself here, because those are opposites, that goes away, equals 120. And then to get rid of that 6, so that x is by itself, I do the opposite of multiplying by 6. I'm going to divide by 6. And I can figure out what x is. 6's go away, because multiplying and dividing are opposites. 120 divided by 6, that's 20. Be careful, make sure you're reading the question again. It's asking the measure of KPL and JPL, so then I actually have to take that x equals 20 and plug it back into the first two. So angle KPL, that was this one on the left, that was 2x plus 24. But now I know what x is 20, so 2 times 20 plus 24, and that's 40 plus 24 is 64. I can do the same thing for angle JPL. That was this one on the right. That I knew was 4x plus 36. But now I know x is 20 again, so 4 times 20 plus 36. That's 116. We can always check our answers. I knew they should have added up to 180. If I take 64 and 116 and add them together, yep, that's 180. So I know I did it right. All right, let's do a couple more problems. Okay, P2, this one is incomplete on your slide. I apologize for that. I think I lost something when I copied it. There should have been some information for this problem. It should have said that AC is an angle bisector. And there should have been a measurement for this angle here saying that was, I believe it was 5x plus 3. And the instructions would be to find x. All right, now P2, instead of being just a picture, is actually a problem. It says ray AC is an angle bisector, find x. Well, if ray AC was an angle bisector, then I know these two angles are equal to each other. So we can write them. 5x plus 3 equals 58. And then we can just do the math to get that x by itself. Opposite of adding 3 is subtracting 3. That gets me to 5x equals 55. Opposite of multiplying by 5 is dividing by 5. So then I get x equals 11. All right, one last question and then our video is done. KM bisects angle JKL. If JKL is 72, what is JKM? Some of us might already think they have the answer. I would recommend anytime you see a geometry question that's just in words, it's always a good idea to sketch it just to make sure you understand the question. Sometimes they can word things tricky, and if you don't sketch it, you could miss something. So I'm going to start by making a sketch of angle JKL. It doesn't say what it is, so I can just make anything up. Here's a J, K is a vertex, right? Here's an L. And then it says KM bisects it, so here's KM. And if it bisects it, I know this angle and this angle are equal. All right, so there's a sketch of that. And then it told me if JKL is 72, so if the whole angle is 72 degrees, what is JKM? Well, JKM would be JKM, that one. So that's just exactly half, right? So the whole thing's 72. I want just half of that because I had an angle bisector. So half of 72, that's 36. This would have to be a 36-degree angle, and that would have to be a 36-degree angle. The measure of angle JKM equals 36 degrees. All right, that is it. Your assignment is section 1.5, page 38. These problems, it looks like a lot. It's really not. A lot of them are just naming things like, hey, true or false, is this a vertical angle? So give that a shot. Again, if you want to ask questions, I'm always available during my Zoom office hour from 1:30 to 3:30. I'll see you guys later.